Hello, everybody. It's great to be here. It's an honor for me. We did something similar to this in Perth a few months ago, and it was really a great session. A lot of energy, a lot of commonalities among mine planners and things that they're challenged with. And I always find it's really healthy for me to have these types of discussions and to hear from lots of people with lots of diverse backgrounds, even though we all are coming to this pretty much at the same with the same objective in mind. So as Jono mentioned, I'm going to talk today about a commodity agnostic approach to handling something that's really important and topical today, and that's around ESG. Before I begin, I want to just make clear that the topic of ESG that I'm looking at and going to expand upon today is just a really narrow vein of the full ESG space. So I'm a mine planner. I've got mine planning experience. This presentation is built with that perception in mind. It's about mine planning and what we can do as strategic mine planners to help our enterprises achieve goals in decarbonization. So you don't have to go very far on a Google search to see a wide variety of enterprises making commitments with regard to decarbonization. Scope 1 or 2 emissions reduction targets. I've pulled a few offline. Some of the major mining houses here would know this more than I. But while you can see there's different magnitudes, there's different timing, and there's different flavors of these, they're all going in the same direction, and that is they're taking decarbonization very seriously. And they're publicly announcing that they're making commitments for emission reduction within the strategic planning horizon. And so the area at which I'm going to discuss today is how can we, as strategic planners, incorporate that into what we're doing, right? We're looking at the life of mine plan. If we've got a commitment that changes materially what we're doing in 2030, and our life of mine is going to go to 2050, we need to include that, and we need to include it as a variable which will influence decisions, not as something that we're going to just post-process in a spreadsheet. The good news is, and we kind of were leaning that way in the beginning of the presentation, is we have existing software, existing technology today that can handle this problem. So the name of that software is Minemax Scheduler. It's been around, as Jono said, for over 20 years. It's been developed extensively during that time to handle lots of different types of strategic planning contexts. So different commodities, different types of plant configurations, processing settings, multi-pit environments, regional environments. And it does it in a way that allows the planner to solve for multiple decisions at the same time the mining sequence is generated. So those types of decisions might be your cutoff grade, it might be the plant destination, might be the way if I'm bypassing or washing coal, it might be what the CapEx needs to be to deliver that plan. Right? All of those things solved simultaneously become a problem where we can model the dynamics and the interrelationships between those variables and come up with a coherent plan that maximizes NPV. So ESG and decarbonization is yet another variable that we can handle in that same architecture, which will influence what we do in the mining sequence, so it should be modeled and optimized at the same time. So there are lots of sources of emissions. I'm just going to talk today about truck emissions and how we can handle that in a mine optimization context. And the reason I want to focus in on truck emissions as mine planners, modeling trucks and the dynamics of haulage over time as pits get deeper and dumps get further or higher and haul routes change, ramps change. Haulage is a big deal. And if you get your haulage right, you can increase the accuracy of your plan significantly. So I'm going to build upon that architecture of modeling an accurate haulage model with your optimization, and we're going to add in some elements such as the emissions generation from that haulage, right? Whether I haul from here to that dump or from here to that process plant, I'm going to have a different cycle time, a different fuel burn, and a different emissions profile, right? And over the life of the mine, I'm going to have a lot of blocks that are going to be evaluated on that sequence. And so the decisions made, if they're considering that emissions variable, will be different than if they aren't. Okay, so we're going to build that model, and I'm going to show you an example of how we do it in the software. And how we're going to bring it all together is to constrain essentially the total emissions footprint to meet the target objective of the enterprise. We'll add up all of those emissions during the optimization, and we'll have a constraint that will limit the amount of emissions we can generate. So if we just left it there, say I've got a constraint in 2030, I've got to reduce my carbon emissions by 50%. If I just left it there, right, we're going to park up a bunch of trucks, and all of a sudden our process plant is half full. So that's not a scenario that any mine planner wants to deliver. So the additional piece of this that's really important is to be able to optimize the timing and instancing of alternative fuel vehicles at the same time as that sequence. So we can see that constraint. We have an existing diesel implementation that's aging. In order to replace that capacity or to expand that capacity to deliver maximum net present value and honor that emissions constraint, we can solve for the timing and instancing of those alternative fuel vehicles. And then as an additional piece, just for a little bit of fun, we also modeled some carbon offset credits. So we've got options to buy more diesel trucks, to buy better electric trucks, or to buy carbon credits on the open market, or any combination of those throughout the schedule. And we're going to let the optimization determine what the best path is. All right. Okay, so I've got some software UI that's embedded in the presentation. I'm just going to play the video. You can see it all go, and then I'll just talk to it so you can see how it all comes together. So the first step is setting up the model. Get that to play. Right up. Thank you. It's going. All right. Excellent. Okay. So the first thing we do is we set up the model. So in Minemax Scheduler, if you're not familiar with it, one of the first things we do is we define the processes, which are capacities that we want to model. And those can be processes related to destinations. They can be processes related to equipment or capacities or downstream logistics or any combination of these things. And so in this model, we have a decision between whether a block is going to go to as ore or waste, right? And then we're going to have a decision as to what truck type we're going to use to haul that material. And then downstream of that, we're going to have fuel consumption and emissions generation. And then we're going to have something called a calculated process, which sums all of those emissions-related processes so that we have a global emissions capacity, which we can control, constrain, and report on. Okay? So that's setting it up in a nutshell. Next is configuring haulage. So if you have cycle times already generated in your project through a different software, you can import them into Scheduler using either as a block model variable or as a lookup table. As long as you cover the full spectrum of possible destinations for every block, you can bring it in. If you don't have it, you can use this onboard calculator. It's going to calculate the return cycle time for every block to every destination because you need to inform the optimization of the burden of cycle time for all options, right? Because it's deciding where material is going to go. And the workflow is simple. You define truck types. You can have more than one truck type. You define your capacities, your speed bins. You bring in your strings. It's going to calculate the cycle on those routes. You can validate it before you get started so that way you know you've got confidence in the model. All right. Next thing we're going to do is import data. So Minemax Scheduler can import Datamine native block model formats. You can also import numerous types of other text file formats. Essentially, we need to bring in the reserve data that defines the geology of your deposit, spatial elements of your deposit, and we're going to map that information to those process variables that I talked about in the decision tree. All right. If you don't have something, you can build an expression in here to calculate it. So for instance, in this model, I don't have fuel burn or emissions generation, so I created expressions to calculate them on the basis of other variables like cycle time in the block model. All right. So all of this is handled through something that we call an import configuration, and they can be as simple or as complex as you like. If you run in Excel, you're pretty familiar with the syntax for how to build these expressions. And essentially, once you build this if you want to change your data, change your block model source, you just import it again, and all these expressions will remain static and calculate based on that new information to populate your reserve. All right? And once you've imported that data, everything remains static. So everything we do beyond that is considered a scenario. The reserve is static, the decisions are known and defined, and the contribution is known and defined. And then in the scenario, we'll define all of the things that will change, right? The parameters for costs, the parameters for recoveries, constraints, precedences, all of those. Okay. So I'm going to walk you through a scenario, which is just an example scenario. So I have a number of scenarios in this model. For this is emissions model. They're built up incrementally. So I'm going to walk you through the last one so you can see how it is built up. Scenarios, as I mentioned, it's hierarchical between a project and a scenario, and you can have multiple scenarios per project. You can define time periods in any horizon that you like. This one is annual time periods for a number of years. If you want to mix up time periods and do quarters in the beginning, you can do that as well. This is a really important section here. This is the financial model that we'll define. So the revenues for the product in terms of the tonnage that we're going to receive. Also, all of the costs, activity-based costs on a unit basis are defined here. I have a range of different costs for both truck types so that if we do purchase battery electric vehicles, we'll know the exact unit costs associated with those. You can see it's a higher cost for a battery electric vehicle and $1 per truck hour basis than it is for a diesel truck. We've got fixed costs. This is your period-based costs. So site G&A or the mill, if I run that mill with 1 ton through it, or your process plant with the full complement, I'm going to achieve that. I'm going to have to incur that fixed cost above and beyond all the unit costs. So that is an appropriate cost model. And then we also have a fixed cost for a battery recharge station for the electric fuel vehicles should that be exercised. This is the capital expenditure definition for the 3 different options that I described before. So the first one is a diesel truck replacement. For $5 million, you get 8,000 hours for a new vehicle. Then we have a new battery electric truck, so twice the price, same amount of hours, and we can control instancing as well. And then lastly, the carbon offset, which I mentioned, is only going to last for 1 year. So if you want to continue to purchase those credits, you have to continue to make those CapEx investments each year as they decline in the following year after. All right? So these are all CapEx options. And the optimization will decide if, when, and how many of them should be exercised. Okay. The next step is going to be further down the track in our precedences. So if we're going to do different mining locations, whether it's strip to strip or phase to phase, that type of spatial relationship needs to be honored, and you want to make sure your mining sequence is following it. You'd set it up in precedences. This is the constraints. Constraints are the backbone of making sure you have a feasible schedule. So in this case, I've got a process plant constraint. It can be represented in maximum, minimums, cumulatives, and differences, and they can change on a period-by-period basis. I've got a constraint on my total truck hours, which is declining over time. Now, this is relating to my diesel truck hours. So if I have a declining constraint representing my total truck hours over time, the fleet is dying, and if I want to maintain my capacity, I got to buy more trucks, right? I have my total emissions constraint there kicking in 2030. I have a total alternative fuel vehicle constraint at 0 from the beginning to the end. That's showing the optimization that I have no alternative fuel vehicles. If I want to buy one, I got to purchase it through CapEx. And lastly, we have spatial constraints. This is your total number of benches you want to turn over if you want to control that on a phase-by-phase basis. You can do that. So all of these constraints, your general and your financial and your regular capacity and location type constraints, they all work together to constrain your feasible solution space. So the solution that's returned will honor all of them. And some of them may be binding in some periods but not in others. And there may be combinations of constraints that are binding some periods other than and not others, right? And so it's a complex problem, and that's how we handle it from a constraint perspective. All right. And last but not least, some results. So just as a screen, a couple of images here. We have a dashboard layout within Scheduler where the My Planner can see the results of scenarios. We've got 3D visualizations, we've got charts and tables, material flow diagrams, financial tables and charts, and all of this just leads to better analysis. So in this particular instance, you can see there's multiple phases being mined. They're being feathered in across time. You can see I've got this purple chart on the top. This is my mill or my process plant. You can see that I've maintained the full capacity until the very end of life. And this is the CapEx result, which shows the capacity and instancing of all of the CapEx options that it decided to purchase. So at the top, you can see that we began to purchase diesel trucks to replace our old ones as they aged. And then we began to purchase battery electric vehicles. The battery electric vehicles can be seen in the yellow bars. And then we began to purchase carbon credits. And you can see there's a line on the bottom of the chart there, which represents the total emissions through that profile. So you can see that we maintain that additional truck capacity even though our emissions was meeting the constraint. This is a constraint table. Optimization modelers love these because this is where you can see all of the constraints operating. If they're binding the schedule, they're highlighted in yellow. So you can see in some periods, there's multiple constraints binding the schedule. All right. Pretty neat stuff. So in summary, what we've done is we've taken an existing model that has haulage as a major element to it in the mine optimization, and we've added activity-based elements to calculate emissions generation for those truck units. And we've created a total project constraint for emissions, and we've used that constraint in time to represent the mandate from the corporate enterprise ESG goal. Then we've solved for the investment related to CapEx for alternative fuel vehicles at the same time that we're solving the mining sequence so that we can have a maximum NPV schedule and secure confidence that that schedule is coherent with haulage and it meets the emissions targets of the corporate goal. So that is it. Happy to take questions.
So just one question. Yep. It's very happy to see the screen. Recording will have the video.
Absolutely. Yep. Yeah, it's higher fidelity on a, yeah.
Make a comment on the question. This is an extremely real situation that's playing out right now. As you said, a lot of big companies are making commitments. I just throw in the mix that yes, not only are we looking at electric vehicles to replace diesel haul trucks, but long conveyors are also coming into the mix again, right? They're capitally expensive, but if you have to reduce emissions, that's a real solution that's also being looked at closely these days.
Thanks, Andrew. Yeah. Yes.
When your objective function is a medium NPV, it's category driven.
Yep. It is a constraint. Yeah, the objective function remains maximizing NPV, and we treat the emissions as a constraint. So any schedule that produces more emissions in the time periods above that constraint, they're infeasible. Yeah. Yeah, it depends on the relationship of your fuel burn to your cycle, which varies depending on the situation, right? There's a lot of variables at play. But if you've modeled your fuel burn appropriately to capture those variables, and then you're converting that fuel burn over to the tons of carbon produced for that haul, then it's accurate. So yeah, it means different things depending on where you're operating. You
let the conditions met by greenhouse carbon credit. Produce too much.
Right. Yeah, so it's kind of neat because it's a trade-off. Like there may be a situation where incrementally it doesn't make sense to buy a whole battery electric truck. So it'll purchase carbon credits instead. It still has to achieve the goal of maximizing NPV. So it's going to choose a combination to get there. Now you could clone this scenario and turn off the capital expenditure option for carbon credits in the new scenario and re-optimize, and then your only options would be battery electric. Yeah, and then if you've got other types of alternative fuel vehicles, you could have those in there as options as well. Yeah.
Got a quick question over here.
Yeah.
One of the things that we use Minemax for pretty extensively is I guess, generating like replacement schedules for trucks. And in the same way that you talked about there, like setting up your capital expansion,
yep.
And let's say it might be for a 10-year period, you know, equivalent to say 60,000 hours, whatever it might be, and then it needs replacing.
Mm-hmm.
I've noticed in the past that I guess the depletion of those hours, let's say that truck's only used for 4,500 within a period.
Yep.
It sort of doesn't roll over. Is that something that's been changed? So I guess what I'm trying to say is if a truck's only utilised for 80% across its life, you might only get 80% of its total life before it's saying it needs to replace that truck.
Right. Yeah. That is an aspect that you have to watch really closely.
Yeah.
Matt, correct me if I'm wrong, but we don't have the cumulative work for that.
Not like that.
Yeah.
There's some painful ways that you can do it.
Yeah.
But not good enough.
Yeah. And I wasn't trying to catch you out. It's just
Yeah.
I haven't really looked into that for a while, so I was wondering whether that's something you're releasing new patches all the time. So.
Yep. I think that one's actually on the list. But at present, we're assuming that the hours consumed by the truck reflect the maximum constraint which the truck has been released to. Yeah. So if you're habitually running low on hours, then we would recommend changing the capacity release on the CapEx to represent that number versus 8,000 or whatever it is. Yeah.
Is there, for the haulage, is there an internal engine that's estimating the cycle times over all the segments? And also, I guess, can it be used to estimate fuel burn? Or is that?
Yeah, so right now it calculates the cycle time based on velocities and grades and all of that stuff, right, delays. It doesn't calculate fuel burn extensively, so what we recommend doing is using a different software to calculate the fuel burn and importing it, or using an expression to calculate it as I have, using constants and variables based on other things. So it doesn't do it specifically, but it is on the list of development items. Yep.
And then it would model it for, I guess, each block mapped to each destination.
Correct. Yeah, it's got to get all the options set up. So if that block could go to one of multiple cells in a given waste dump, one of multiple process plants or stockpiles, all of those will be calculated because they're all options to the optimization, and we don't know where that block is going to go until we solve it, right? Because it depends on timing and all that other stuff. All right, well, thank you very much. Appreciate your time.